the new pods is matching. Actually, Karpenter is at least from the user perspective, like three main CRs, I guess. Or is there more than that? NodeClass, NodePool,
It,
and NodeClaim, or did we have more than that?
um, officially the ones that we focus or as a user, the ones that you're gonna be interacting with the most are NodePool and easy to know or NodeClass.
Okay,
No
we'll go ahead and
claims,
explain how
no claims
NodeClaims.
base. Yeah, no claims. It's part of the what Jonathan was mentioning and on the work that the team did on how to make it portable, so to speak, or easier to maintain the state of the instances that or the servers that it's going to create.
Okay,
But what I start with the book in the first sections is basically kind of like a recap of what we already know, that at some point the cluster is going to be constrained when you're adding more pods into the cluster. So you're going to have unscheduled pods. And this is basically on the previous chapter, I mentioned that either cluster autoscaler or Karpenter is going to take action. And I wanted to emphasize this from the very beginning because usually when I don't know how it is right now, but in the past, when we were talking about Karpenter, the idea that I got from people is that Carpenter, yeah, it's awesome, but they got the idea that it's gonna do everything, and that Carpenter was gonna take charge of scheduling and a lot of things. So I wanted to make sure that this is very clear from the very beginning that Carpenter is gonna react only when you have unscheduled pods. And the way that I love how the team frame it is that it works in tandem with the kube scheduler. That means
yep.
that Carpenter is going to anticipate or trying to anticipate to what the kube scheduler is going to do, and it's going to create the capacity that those unscheduled pods needs and only what they need. Jonathan, I guess you want to add something.
Yeah, I was gonna say there's I'll add an addendum to that, which is like that's fundamentally true. There has been a feature that was released, I think, two minor versions ago, which is static capacity, which is kind of meant to give you the support that people
That's true.
wanted that
Yeah.
was more in line with like MNG managed node groups on EKS, which is you can create a static set of nodes that don't require any pods to be run on it. And then there's also some thinking around how do we kind of reserve capacity ahead of time for pods for something like queue where I need to make sure that I have a certain set of or like gang scheduling use cases like I need to make sure that I have a certain set of pods ahead of time or a certain set of capacity ahead of time so that I can run my entire
Yeah.
job across multiple nodes. So both of those are cases where you may not have like live capacity that you actually need to schedule. But it's kind of like an exception to the rule. I would say in general, those use cases are kind of exceptional, and most of the time, yeah, it's only going to schedule the capacity that you need.
To create like a
Yeah.
warm pool, right? The second one is to the warm pool or the requirement that the end user is like, it takes seconds to for the pod to be ready or minutes. Takes 2 minutes, and they want like the node to be ready in less than seconds. So they know somebody needs to create that node beforehand, and there's some tricks, not tricks, but practices even in cluster autoscaler that you created like low priority pods just to be parked there. So when the pod comes in, it kicks out that one and comes in. So you said that there's a
Yep.
new features just to create them empty.
Yep. Static capacity. You can set a replica count on a node pool, and that basically will enable you to get that number of nodes.
Nice,
You can you can
nice.
you can you can find a blueprint about that in the repo. We just recently published it, by the way. But I think that expect to get more blueprints, especially what Jonathan was mentioning there. This is mainly driven by the AI workloads that we've been looking at, how people is starting to deploy more and more in a Kubernetes environment. So this is true, for example, when you do a training job and you need to have a certain nodes ready. Otherwise, the training is not gonna run. This is basically what Jonathan mentioned as well, or referred to as well as gang scheduling. And there are gonna be times where you already paid for capacity or reserved capacity, and you're already paying for it. So you might want to have the capacity over there. So I guess that as the project mature and evolved, we've been covering more and more. I wouldn't say edge cases, but more and more patterns that we see from customers running workloads on Kubernetes and how Karpenter can fulfill those needs.
Yeah, it's a good thing that it's driven through use cases versus coming up with a feature. And then once there's that many end users asking for the same feature or the problem that is not covered today, then Karpenter right can come up with the solution. I'll
Yeah.
take one question. If Touch, you have a question? You have your hand raised?
Yes, one note regarding the static. We're currently reviewing the solution or the offering for static replicas. One note that I saw in the documentation I thought it's worthwhile mentioning is that for any users that have pre-existing node pools that they want to add that parameter to them, it's a one-way street. Meaning once those node pools become static, they cannot become dynamic anymore. So if you want to have a static node pool, you should preferably create a node pool from scratch instead of updating a pre-existing node pool. That's per the documentation. That's one call out.
Good catch. Yeah, good call out.
Yeah, thank you. All right, so I guess that let me progress a little bit on the book. I start to explain how this works on AWS, because remember that we were coming from cluster autoscaler, managed node groups, kind of like defining before we start to deploy workloads into the cluster, the type of node groups that we're going to have in the cluster. So we had to anticipate into that. And the reason why I'm highlighting that is because the way that I talk about it in the book is that with Karpenter, you don't need to actually do that. Because at some point you might have if you see in this diagram, you have kind of like a node group with homogeneous instance types here from that could have same memory and CPU, regardless of the family or generation that they could have. But with Karpenter, you might end up with a mix of different sizes, architectures, families, generations into the cluster, and that's basically the idea of how Karpenter is trying to make the cluster as efficient as possible. And that the way that I like to explain this is that with Karpenter, you have an application first approach where based on those unscheduled pods that you have in the cluster, Karpenter takes those constraints from the pods, and based on that, it's going to launch only the capacity that it needs. It means that it's going to launch the capacity that the workloads are requesting to, instead of saying, like, hey, we have just 2-3 unscheduled pods, and then add X number of nodes, and that's it, right? So Karpenter takes a different approach here on when launching the nodes into the cluster.
And a quick question. Maybe Jonathan knows, since we're taking advantage of a maintainer here. When a pod gets when does Karpenter triggers a pod? Like, for example, if I create a pod, one, like, a Karpenter will take, and then we'll see where it will fit. Like, it takes a pod that is pending, but if like 5 of them come in, or they're closely together created, does Karpenter waits enough to say, like, hey, let me see if there's like more pods being pending, than start like doing simulations and then taking to where do I put this pod, where like 4 more are joining like 2 milliseconds after, and then like, oh my god, I could have just created a node to fit the 5 of them instead of creating for 1. That makes sense?
Yeah, it makes sense. I think so. The scheduling loop, if you were to like dig into the details of the code, it runs in a single thread, which kind of fundamentally makes sense because I think KeepScheduler does a similar thing. and it will basically loop continually. And it is triggered when it sees one pending pod effectively. But when it gets its first trigger, so when it first sees that initial pending pod, it will wait up to basically there's a setting that you can set that's like I think it's called like the batch timeout or something like that. And there's a
Yeah.
batch idle and then there's a batch timeout. And batch idle is basically like how much time between the last pending pod should I wait? If I don't see another pending pod, then I go and start scheduling. And then the timeout is like the full time, basically. So it's like, even if I continually see, like if my idle timeout is 1 second, if I continually see pods every second, I will eventually like start scheduling. And I think the default is 10 seconds. So maximally, after you see the first pending pod, you'll wait 10 seconds and then it will start going and trying to schedule. So in your example where you have multiple pods coming in like milliseconds after each other, it would see all of those because it would continually like re-trigger that batching code. And then it would start once it basically stops seeing those new pods. So it would schedule all of those at once.
Great. I also had that question, and also someone asked me that question because you could assume like we were talking about in general, right? One pod comes in and then you create a node, and it's an expensive task, right? That then go back. So I think it's good to have this, and then also it can be customized depending on like the corner case that you have. Right. Okay. Good. Christian.
Yeah, I'm sharing the exact diagram that we were discussing a minute ago. This goes a little bit further into the chapters of the book, where I'm sorry, in this chapter, where it basically I go in more details on how it launches the nodes, and there are 4 elements or phases of this. The first one is going to be scheduling, batching, bin packing, and making the request. So yeah, this is basically what Jonathan just described on the batching, and here I highlighted the environment variables that you will need to change in case you want to do it. General recommendation: don't change it if you don't know what the implications are. But yeah, depending on your use case, you're a responsible adult with this if you want to change it and make sure that you understand the impact.
Yeah,
Okay.
I would say in general, like if you increase the like, I would generally not recommend people decrease these settings. If you increase these settings, then it reduces your reactivity. Basically, it kind of intuitively makes sense. Like if you increase the time that you wait, then you're going to move slower. The trade-off of that is that you end up generally creating bigger nodes because you'll batch more things together. But it's kind of, unfortunately, it's a little non-deterministic in the sense that like depending on the node or the pods that come in, then you can possibly not, you may get multiple nodes, those kinds of things. So I think in general, like Christian said, it's like unless you are okay with that reduced reactivity and like you are just seeing Karpenter continually bin pack really small nodes for some reason, it's like not recommended. And honestly, we when we were originally building this out, I would say this is a level of configurability that I think we kind of fundamentally disagreed with having early on because I think one of the thing I wanted to mention earlier, which was like one of the fundamental tenets of why kind of Karpenter came out of like there was initial conversations of integrating some of these similar design paradigms with cluster autoscaler. And I think it got to the point where cluster autoscaler had too much configurability. So okay, one of the fundamental tenets that Karpenter was trying to adopt is okay, let's make these things simpler. Let's create less configurability. Let's make things simpler. The unfortunate part is I think scheduling is just like a fundamentally difficult problem. So there is just like a level of complexity that exists inside of it. And as we've tried to increase use cases, like there just unfortunately is like irreducible complexity that has come. But I think in general, we've tried to adopt the mindset of, okay, less configuration is better. Just do things that are intuitive to the user. My opinion is that the setting is not one of those settings that's necessarily intuitive, and maybe we shouldn't have it, but there you go.
Interesting. Good insight. Yeah, let's go back to the top on talking about the EC2 NodeClass.
Yeah.
I think NodeClass and NodePool, right? Like, what is the misconception there, or maybe like, what is the scope of the EC2 class? And then we go into NodePool, which I think it has the most variants of configuration that people talk to. Itash, you have a quick question or comment? I see your hands
Yes,
up.
thank you. Thank you, Carlos. A question for Christian. I think either you or was mentioned earlier regarding the increased usage for AI workloads, utilizing Karpenter's dynamic scheduling or dynamic provisioning. I did follow up on the Karpenter blueprint, specifically in the usage of the SOCI snapshotter to increase increase velocity for image pull time, as well as updating the IO and the configuration for the EBS volume. Do you see any further evolution or additional features expected to make Karpenter much more, improve on the support for running heavy SID models? I don't know if it's also related to the wait time for the pods, specifically for the image pull times as well. Utilizing solutions, obviously, on the AWS plane, such as the ECR VPC endpoint to increase or decrease the pull times for the images as well. But do you have any other best practices to allow Karpenter to become a main player for running AI workloads on Kubernetes? Thank you.
Yeah. Jan and I have been actually, we did a session in February in London about it, and I cover few topics about it into how to autoscale VLLM based workloads, basically. To answer your question, it's not only about this SOCI, which we call Sochi. That's only one part of it, that it helps on pooling of the images. Typically, these images are huge in terms of 10 gigabytes of space, simply because of the CUDA operators and things like that that are needed to run GPU-based workloads. But there are other things that enter into consideration as well. It's not only about the images, but also about the model weights. And VLM has a streamer from NVIDIA, for example, that is pretty awesome, and that it's going to help you to load the model very quickly. There are other things into consideration as well. Contrary to what people might think, I was actually very skeptical of this, but using S3 as a backend for example, for the model weights, it's surprisingly really fast. You can get a bandwidth really high. And actually, in the demo that I was referring to before with Jan, I created a dashboard where we were actually trying to educate or showcase the power of Karpenter and Kera and the metrics that we talked about before that you might not want to scale on CPU and memory. And this is especially true with GPU-based workloads. So we talk about that scaling modifiers, the metrics that you can use, and then we cover the part of Karpenter. Sochi was one of that. S3 for model weights as well was that. And then, for example, leveraging VPC endpoints, like you were saying, with S3 with VPC, so that you don't go to the internet. But yeah, this can easily go into the weeds, and we can dedicate a whole episode talking about that.
Maybe we do
I'm working with a
a book or
team.
session.
Yeah. I'm working with a team on documenting these best practices. But if you happy, when I have time to go into my GitHub repo, I can share the repo that we use, because that demo is already there, and I go deeper into that. So can share that in a moment.
Cool. Yeah, share that and then we can add it to the notes.
Thank you.
Stack, for the question. Yeah, so EC2 NodeClass. I think at the bottom you have the YAML, right, of the things that you can put here.
Essentially, the NodeClass is basically how you define how your instances are gonna look like. And referring to what Jonathan was saying, the idea is to keep this as simple as possible, and to I guess that the simplest configuration that I can show you here right now is that you specify the IAM role that each node is gonna have when running, and AMI selectors. In this case, this is the easiest way to say like, hey, this is gonna use Bottle Rocket. This is the version that it's gonna use. You can use latest, of course, but be aware that when a new version is released, your nodes are gonna be forced to be updated because of this, right? So that's why I wanted to, even though I knew that this is gonna, the 1.24 was gonna be outdated very quickly for Model Rocket, I wanted to leave it here just to make sure that people is not using latest. But yeah, you can specify this, and then you can specify the subnets and the security groups that you can have for these specific nodes when you're launching. And you can do all sorts of things, but to get started, I just wanted to keep it simple and say like, hey, this is how you define how the node will look like. And this is specifically for EC2, and for other providers and other implementations, the details on how you specify and what you can specify here are going to change. They might use any other label instead of AMI selectors, or AMI selectors might use image only or things like that. But this is basically how the settings of how the node will look like.
So Christian, one thing just to make people aware, at least the most common thing about this EC2 class is upgrades. That people, right? You can have more than one EC2. If you go up, this EC2 class has a name, so you can have a couple, right? It has default. But the thing that I think misconception people have with Karpenter is they think when they create a node pool, they think they're still thinking about in terms of like manage node groups. That if they create a node pool, and let's say you're a platform engineer, you have multi-tenancy, you create a node pool and you dedicated that to team 1 and dedicate to team 2. When you're going to do upgrades, if all of the node pools point to the same EC2 node class, the minute that you upgrade the version of the Kubernetes for the worker nodes, then that will affect every node pool in the cluster, right? And a Karpenter will start doing the upgrades, and then that's Karpenter would do it in a smart way. Don't worry about it, right? We'll respect PDBs. It would do it but it's something that people may not realize, that if you change something here, affects all the node pools that are pointing to this one. So you have the flexibility of creating a node pool and pointing to something different for the version, or if it could be for something else, but most likely the version. So when you do upgrades, you have to watch that. And then what you said latest, that maybe it could be for dev environments, or maybe some certain environments that you want to follow the control plane. So when the control plane upgrades, then this one just starts seeing the new AMI showing up with the new version, and it will start rotating. And lastly, I would say we have something in AWS called Auto Mode. That is a special type of EC2 node class. It's in like an AWS EC2 node class that you don't you're not in charge of creating that upgrading the version. Like we upgraded up to, you cannot go more than 21 days with the same version of the AMI patches and CV. So we take care of the patches, but take into account that the nodes will upgrade. I think that's the only thing that for NodeClasses are like, people are looking, where do I put the version of Kubernetes in NodePool, and they cannot find it in the NodePool because it's not there, right? It's in the EC2 node class.
Yes, exactly. So this is so important that in the scripts of the book, what I did is that I version all the node classes to latest, but because I was trying to fix the version, but it was getting broken every 3-4 months because it was already too old and you cannot use that image. So, but this is so important that I leave it to latest. And when you run the script to bootstrap the cluster, it replaces
flip it
latest with the latest canonical number. That's how important it is to keep that. I found the link. I'm gonna share it in the chat. that I was
Oh,
referring to
thank you.
before.
I'll grab it to
And
put it into the notes.
yeah, and yeah, of course. These, by the way, these are not the only things that you can specify or change in a node class. But like I said before, I wanted to keep it simple. And if you want to go deeper into this, of course, there are a few patterns and a few other labels you can find in the official docs and in the Karpenter blueprints as well. You can, for example, modify user data, uh, um, or even change the disks proportion that you might need, all those sort of things.
Or no config structure, right?
Say that? Say that again?
A node config type of structure
Yeah.
input.
Yeah. So it's kind of like, for me, NodeClass is like a template
Yeah.
of a node, I would say. And then because you need a structure and an order, you need first a node class, and then you can start with the node pool. And this is basically the CRD, I would say, the one that you will interact the most, and where you will be impacting how Karpenter will work the most. And this is basically how you define the constraints or the requirements that Karpenter will take into consideration when you have those unscheduled pods. Effectively, what it's gonna do is that you have your unscheduled pods. Those unscheduled pods have constraints like node selectors, then affinities, tolerations, spread constraints, and things like that. And it's
Architecture, right? If you want ARM or your image only supports AMD 64, right?
Exactly.
Then you have to your workload, right? Your workload says AMD 64. You have to say I only need I require an instance with basically the workload is saying the requirements, right? What absolutely it needs, or
yes,
or the group of things that it can work with, right? You put in the requirements.
Yeah, exactly. Then Karpenter, what it's gonna do is gonna take those constraints and it's gonna match them with a node pool. Of course, the node pool doesn't have to be one-to-one relationship. So you could have, like, for example, instance category of C, M, and R, and your pod could have C for 8x large, or it
I
could
think
have
you can scroll down to the YAML. I think that's the samples
Yeah.
that you're reading.
Yeah, sorry. Yeah, this is basically the CRD or the manifest that you're gonna have for an OPU. You can specify things like it supports only AMD, not other architecture, because your applications might not be ready to use other architecture. You can specify that it runs only, that it's gonna launch only Linux nodes. The capacity type, for example, on-demand, spot, reserved, instance category, as I was saying before. And just with all of this, with these requirements that you have here, you define or scope. For example, in AWS, you have more than 1,000 instance types. With this, you restrict to, let's say, to 600 instance types, to give a number. Of that number of instance types, Karpenter can choose from the ones that adapt, or basically on the bean packing algorithm that, or step that we were talking about before, it's going to try to launch the capacity that it needs, and it's going to try to match which instance types from this universe that you define here match with those requirements.
And requirements are kind of a positive and right. This is an and what are the things to scope it down to that. So what most common question is, I get from end users, it's like, what do I put in this section to avoid Karpenter spinning up a large instance that costs a lot of money, and just make it like from this size or a range, or no larger than X.
That's a very tricky question, and it's a common question as well. But one thing that I like to say to customers is that rest assured, because what happens is that when you have those unscheduled pods, Karpenter aggregates those resources, and then based on that, it's gonna start filtering the list of instance types. Of course, one of those instance types are gonna be the bigger ones, but Karpenter, if it's for example, on demand, which is the simplest right now, it's gonna sort that on the cheapest one. So a smaller instance type is always gonna be cheaper than a bigger one. So that can leave you with that confidence that it's gonna be pretty weird unless you have some constraints in your workloads that it's gonna end up launching more compute capacity than you actually need.
And I think we go back to like the first best practice or requirement that I give end users is you have to put those containers or those pods needs to have a request memory and
Yes.
CPU. So for Karpenter to help you, right? If you don't put
Yes.
how much CPU and memory every pod gets, and you can use things like limit ranges to be like best F or put a default, then specify.
Yeah.
But absolutely, that's what drives the auto scaling is putting a request, not limits, request. That way,
Yes.
what you're saying is you're not going to get a large image, because if you're getting a large image, it's because you're requesting pods that the summation of them give you a big image. But if you put the right size, 500 megabytes, 100 M of CPU, right? Those pods are small, containers are small. That's the job of Karpenter. Maximize the efficiency to give you the smallest image that I can fit your request. But if you don't put requests, it's just going to do best effort
Exactly.
on it.
Exactly.
Oh, there's a limit on CPU here, right? Of like, even though you
Yes.
create not create 1 million instances, right? Something like that. But you can cap with the CPU memory or your
And
CPU. I cannot remember.
CPU memory, and now with nodes with the static capacity, which is something
Oh,
new.
okay.
Yeah. But yeah, this is a way of I was always getting the question, hey, but how do we control this? Because in the past we have with Autoscaling group, for example, you have the minimum and maximum capacity, so you can sort of control the maximum capacity that you can launch. In this case, Karpenter takes a different approach. You can still limit how much capacity it can launch, but instead of saying like, hey, these are the number of nodes that you can launch if it's not a static capacity, you specify the number of CPUs or in total that it can launch. Because again, it could be 5 smaller instance types, or it could be one big node, and the sum of those could be more PCPU. So that's basically it. Yeah. Then I guess that I spend a lot of time on the requirements here, talking about what does that mean and how you can the type of requirements that you can get. You can specify, for example, the generation, the family, the size, the CPU, the number of CPUs that you could have, the ranges of memory that you could have. This is another way of controlling. What I find, what I usually see some customers are doing is like, hey, we would like to set a range of requirements of CPU and memory that we can launch. Let's say, for example, that I don't want to launch multiple smaller nodes because I get charged for every node for a monitoring tool or for something else. I get charged by node. So I would like to reduce as much as possible the number of nodes that I have or that I launch. So you can there I see customers saying like, hey, I just want to be able to launch nodes that have 4, 8, 12, 16, 32, and 64 CPUs, and that's it. Don't go above that and don't go below that because I don't need them. Of course, customers have their own reasons, but one of them is basically I want to reduce the number of nodes that I could launch, and they let Karpenter to decide how many to launch.
Interesting.
We have a question from Touch or comment.
Go ahead, Touch.
Thank you. Question regarding, oh, it eluded me. Sorry, I was waiting. I was focused on the topic that Christian was talking about. I forgot my question. Yeah, I'll
No
remember it
worries.
in a minute.
No
Thank
worries,
you.
no worries. All right, so yeah, I guess that I go deeper into this and explain what each requirement means, the general
And
recommendations.
some of these are included here, like the generation and the type that you can put just the first letter, right? CMR, but you can also say
Yes,
like I want C8, for example, or C8I. You don't have to say
exactly.
C, but you can be more specific and then reduce the options, right? Of like the ones that you want to get. It could be like CAI or MII, which are like the ones that support nested virtualization, for example.
Yeah, exactly. Or actually, you can do the contrary as well. I've seen some customers saying like, "Hey, this family in specifically, I don't know why it doesn't work very well with my workload, so I would like to do an
Exclude.
exclusion." And you can say not in, and it will filter those instead of filtering the complete C family or category, you can just filter C5A
Oh,
for some
okay. So
reason.
you're talking about the operator. Usually in all examples, we see operator in, where you say
Yeah,
that the operator supports in and not in, those two,
not
or
in,
there's a third
exactly.
one?
In, not in, and greater than as well,
And greater than for the,
and
yeah,
low,
for the
and lower
instance
than as
generation
well.
makes sense.
Yeah, yeah,
Great. So this, yeah, it's a similar of what we do with labels, selectors.
yes. And I guess that the last CRD that I would like to discuss here is the node claims. And we don't need to go too much deeper into why we created them or why Carpenter created them, but if we think about it, you most likely are not gonna be creating node claims, although I've seen people and customers doing it, but the general recommendation is not to create node claims. Karpenter will create one when it's basically a representation of the node that it's gonna create. And the way that I find them, the reason why I found them useful, it's for troubleshooting purposes. For
Yep,
each
I agree.
node that you have in the cluster, you have a node respective node claim, and it's really nice because you can go and explore that node claim, and you can see the list of instance types that were considered to end up launching the node that you have. So I get a very common question that I get is, hey, but Carpenter ended up launching this instance type where I know that this was the cheapest one. And when they go and explore the list, guess what? There were others that were expensive, or if it was a spot, then the conversation changes. But it's a really good way of troubleshooting. And you also have the events, which is something that I learned from Jonathan Initz as well, that when he was doing the feedback, to leverage a lot of the events because they put a lot of information that useful for troubleshooting. That, for example, if you inspect the no claims, you can easily see why it's not being consolidated, why it's not being replaced because there's a drift or things like that. You can actually see that. And is where I explore that later in the book, but I actually put a list of events that were
Stat
available at that date. Yeah, and so that you can see which type of events are Carpenter is going to report to
And it
this
has a
different
status,
update
right? So it has a
as
status
well.
that you
Yep,
can inspect. And I would say that now with these AI op tools, right? The AI op agent can
exactly.
analyze these no claims,
Yeah,
right? That information is sitting there and actually give you like a portal or a summary or a human way of troubleshooting.
exactly.
The other thing I would say is like for events, we have to watch out because events get deleted. So if you are a
Yeah,
production
that's true.
system, right, you want to get those events into your logging system or convert them into metrics with something state metrics, but that's something that disappears. So you go 2 hours
Yeah,
later or
that's cool.
something, the events will not be there, but they should be captured in production systems, so you can go back to your observability stack and look at that. I think we're up on time, and Itach has a comment. So let's take that comment or question, Itach.
Thank you. I remember my question. One of the regarding Karpenter's scheduling or choosing the most suitable node or instance type based on set of parameters, obviously, and when it looks into the requirements fields or the requirement list in the NodePool. One thing that we've noticed where Karpenter, like a scheduler, or more precisely a provisioner to handle pending workloads, many of our workloads, or not many, but essentially a couple of our workloads are either EKS add-ons and also on our own, and some of them are they essentially they are daemon sets, so they spin up on all new nodes. And is there any thought to configure Karpenter to take a look into the NodePools tolerations and affinity configuration, the toleration, and look at the workload's affinity and take into account also the prospective daemon set that would come up and get scheduled on this new prospective nodes in terms of impacting or affecting the most suitable node to not only house the pending workload, but the bundled workload that would get scheduled on that node as well. Monitoring agents, guard duty, the list is long. Obviously, and you know the list of EKS add-ons better than me. But we get this issue sometimes where Karpenter would like to schedule the most cost and performance performance aware but cost centric option. But sometimes certain workloads, daemon sets specifically, they get left out. And we can solve that depending on each of the add-ons configuration JSON, as you're aware, to set the priority class. But for either specifically, do we feel that there's a way forward to take into account those bundled workloads, daemon sets, in scheduling, or choosing the right and appropriate instance size?
Not sure what problems you're seeing, but daemon sets are being considered when Karpenter is gonna launch the nodes. There are gonna be some daemon sets that are gonna have taints, temporary taints, and you can configure those as a startup taints in the NodePools. For example, those daemon sets are gonna have temporary taints, and then you can let them to be scheduled there. Sorry, Carlos.
Yeah. Christian, what you're saying is that this is already like if I put too many things in the question, but at least one of them is when Karpenter is going to pick a node size, it needs to pick up a size that is like, I need to fit all these pods that are daemon sets. It could be like 50 of them, each one taking one CPU, right?
Yeah.
And then there's no left to put like the pods that is pending. So you're saying that that's already being considered, that the node needs to be large enough to fit the daemon sets, the NodePool, and then the Kubernetes reserve, thing is it's a reserve thing that you configure in the EC2 NodeClass. You said that it's already considering like the pods that are daemon sets plus the pods of the workload to size it.
Yes.
But they shouldn't be left out, right?
No, they shouldn't. If you go deeper and explore this into Beam packing, I explained this in this page, where effectively what it does. This is a very simplified version of what it does. It's pretty interesting because what it does is that it orders the unscheduled pods based on CPU and memory, takes the biggest one and say, hey, the biggest one, this instance type is the one that will fit in. Then it goes to the next pods and say like, okay, I have more pods that I need to schedule. of course, all of this happens in a matter of milliseconds, microseconds, right? And says like, okay, I forget about this instance type because it's too small. Now that the requirements change, and I need to consider other instance types. So it's gonna say like, hey, I need this one. Then it's gonna say, I have more pods, and it's gonna start. You can see here that it's considering bigger and bigger nodes as it progresses. So if I know that people have reported some edge cases, specifically with daemon sets, but I think that the Karpenter team has been addressed many of them. If you still see that problem, it's better to reach out to the GitHub repos or issues if someone is already reported that,
Already open it.
or if,
Yeah.
or if not, open it. But because that shouldn't be the case.
Thank you, Christian. I appreciate the input and feedback. Thank you.
Sure.
Yeah, it
And
makes
yes,
sense, right? Because Demon said we didn't talk about Demon says, but that's a good thing that Itash brought it up.
Yep.
Okay, so I think the plan is to. I think we still have more Karpenter to cover it. Right?
Yes.